Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aminul Rafi bin Syed Azman and I am physicist student. Today I will going to talk about tokamak. So what is the tokamak? But before that I will explain to you what is the energy. Energy is an important element in daily life since it uses many activities like moving vehicles, promoting growth and human body, enabling human to think. However, energy can be found in various forms like sound, heat, motion, and light. Well, there are also kinetic and potential energy. Kinetic energy. What is kinetic energy? Kinetic energy is the motion of substance, waves, objects, molecules, and atoms. And potential energy. Potential energy is the gravitational or stored energy. Some of the major kinetic energy is thermal energy, electrical, motion, and sound, while potential energy includes nuclear and chemical. Next, I will explain to you about the most important energy in our life, which is electrical energy. So, what is the electrical energy? Electrical energy is caused by a moving electric charge called electrons. The faster the charge moves, the more electrical energy they carry. As the charge that cause the energy are moving, electrical energy is also a form of kinetic energy. The example of the electrical source is lightning, batteries, and electric eels. You probably know that most of the electricity you use is produced in a power plant and travel to your home and school through a special wires. But do you know what the energy source are used to run the power plant? So there are two energy sources that run the power plant, which are the non-renewable resource and then the renewable resource.
For example, is a fossil fuels.
Let's check it out. What is that?
Which include coal, oil, and natural gas.
Non-renewable resources is a
renewable
resource that
because
can be used
it
up.
took millions of years for them to form. Once we use up our fossil fuels, they will be gone for good. Many power plants use fossil fuel. The fossil fuel is burned to produce heat, which is used to make steam. The steam is then used to turn the blade of turbine. Some of power plants run on nuclear power, which is another non-renewable resource. Nuclear power rely on uranium, a type of metal that is mined from the ground and specially processed. Heat released from splitting uranium atom is used to convert water into steam that turn the turbine and then produce electric. For example is wood, wine, sunshine, geothermal energy, biomass, water stored behind the dam in lakes and reservoir. Electricity can be produced using several kinds of renewable resources. Wind energy can produce electricity in regions with standby wind blows. Giant wind turbines capture the wind energy and use it to power generators. Biomass. Biomass is the material that is formed from living organisms, such as wood, agriculture waste. Biomass can be burned to produce electricity or convert to the gas and used for a fuel. Next is geothermal energy. Uses hot water or steam from deep beneath the Earth's surface to produce electricity. Next, hydroelectric power. Hydroelectric power is generated using the energy created by falling water to spin the generator turbine of hydroelectric power plant and make electricity. Next, solar energy. Solar energy can also be used to produce electricity. Solar cells change the radiant energy of the sun into electrical energy.
Next, in Malaysia, what is the kind of the energy resources that used to generate electric? So, Malaysia is an industrial market economy. About 40% of the country's revenue is generated from oil and gas export. Therefore, it is not surprising to note that the fossil fuel is the primary source for electricity generation. According to data from the National Energy Balance 2010, 43% of the electricity generation is made by natural gas, 40% is made by coal, and 7% made by the hydro. Next, I will explain about the nuclear energy. As we know, nowadays, there are many modern countries that use the nuclear energy to generate their electricity, such as in Japan, China, United States, Great Britain, and Russia. So what is the nuclear energy? The foundation of the nuclear energy is the harnessing the power of atoms. That there are two mechanisms, which is fission and fusion. Fission and fusion are nuclear process by which atoms are altered to create energy. The create energy is heat in the form of heat that will make the water to become a steam to move the turbine. So what is the difference between the fusion and fission? Simply put, fission is the division of one atom into two, and fusion is combination of two lighter atoms into the larger one, and both of it will produce energy. They are opposing process and they are very different. So the word fission means a splitting or breaking into parts. Nuclear fission releases heat energy by splitting atoms, while the fusion is combine two small particles and will produce a big atom that will give a big energy. Next, by the end of the century, the demand of energy will have triple times under the combined of pressure of population growth, increase of the urbanization, expanding access to electricity to the developing country. So the fossil fuel that shaped the 19th and 20th century civilization can only be relied on the cause of greenhouse gases and the pollution. Therefore, a new large-scale, sustainable, and a carbon-free form of energy is urgently needed. Therefore, nowadays there are many modern countries use a nuclear fission reaction or reactor to generate their electricity, such as in Japan, in China, in United States, and Great Britain. For the nuclear fusion reactor, in this world nowadays only a few and less than the nuclear fission reactor, because it's still in experiment. However, the nuclear fusion is a reactor or a resource is more advantage than the nuclear fission. There are few advantages that make fusion worth pursuing. The first one is abundant energy. The fusion atoms together in a controlled way release nearly 4 million times more energy than a chemical reaction, such as the burning coal, oil, and the natural gas, and 4 times as much as a nuclear fission reaction at this equal mass. Fusion has the potential to provide the kind of the best load energy needed to provide electricity to our cities and our industries. Second advantage that we can get from use the fusion resources is sustainability, because fusion fuels are widely available and nearly exhaustible. Deuterium can be distilled from all forms of water, while deuterium will be produced during the reaction of fusion as fusion neutron interact with the lithium. The third one advantage is no carbon dioxide. Fusion doesn't emit harmful toxic like carbon dioxide or other greenhouse gases into atmosphere. Its major byproduct is the helium, inert gas, and non-toxic gas. So the first advantage for using the fusion reactor is the limited risk of proliferation. Fusion doesn't employ fissile material like uranium and plutonium. The radioactive tritium is neither of fission nor a fissionable material. There are no enriched material in the fusion fusion reactor like ITER that could be exploited to be a nuclear weapon. And the last one advantage is the no risk of meltdown. As we know, in the Fukushima, a Fukushima type nuclear accident is not possible in a tokamak fusion device. It is a difficult condition necessary for fusion. If any disturbance occur, the plasma will cool with a second and the reaction will stop. The quantity of the fuel present in the vessel at any one time is enough for a few seconds, and only there is no risk of a chain reaction. So we are going to talk about the main topic, which is tokamak. As we know, the power plant everywhere generates electricity by converting a mechanical energy to the electrical energy, such as the rotation of the turbine into the electrical power. In a coal-fired steam station, the combustion of the coal turns the water into a steam, and the steam will turn the turbine to generate electric. So, the power plant today rely either the fossil fuel, nuclear fission, or the renewable resources such as hydro. For the tokamak is an experimental machine that designed to harness the fusion energy. Inside the tokamak, the energy produced through the fusion of atom is absorbed as heat in the wall of the vessel. Just like a conventional power plant, a fusion power plant or tokamak will use the heat to produce a steam that generate the turbine, so a turbine, and the turbine will generate electric. We're not yet aware. The operation of ITER is the name of the nuclear fusion reactor. We already know the nuclear fusion reactor is known as a tokamak. So we must know what is the history of the tokamak. So actually in 1920s, there are many scientists that obtained the first insight into the physics of the sunshine, when the sun and the other star transmute matter, tirelessly transforming hydrogen into the helium by the process of fusion. They release a colossal amount of energy. Then, by the mid of 1950s, a fusion machine were operating in the Soviet Union, United States, United Kingdom, and Japan. Then the harnessing the energy of the star was the proof a formidable task. After pioneering works in the Soviet Union in the late of 1950s, a donut-shaped device called a tokamak was to become the dominant concept the fusion researcher. Since then, tokamak has passed many experiments. Then, in the 1990s, the experiment with actual fusion fuel, which is a mix of hydrogen isotope, which is deuterium and tritium, began in the tokamak fusion test reactor, or we call it TFTR, in the United States, and the Joint European Tours, or we call it JET, in the United Kingdom. JET marked a key step in international collaboration, and in 1991, they achieved the first one, or the world first control release fusion power. This is the first achievement about how to control a fusion power plant. After we know the history of tokamak, we must know how the tokamak works, how the mechanism of tokamak. So, but before that, in order to make sure or to make the fusion reaction occurs, we must consider two important things, which is the temperature and the pressure must be extremely high. So, first, to start the process, air impurities at the vessel. As we know, the tokamak is a donut-shaped vacuum chamber. So, before it, we must air and impurities in the chambers, we must evacuate it from the chambers. And then, inside it, under the influence of extreme heat and pressure, gaseous hydrogen heat become a plasma, which is a hot and electrically charged gas, which is the same in a star. And plasma provide the environment in which light element can fuse and yield energy. The charged particle of the plasma can be shaped and controlled by the massive magnetic core places among the vessel. Physicists use this important property to confine the hot plasma away from the vessel, because when the very hot plasma reach or touch the vessel, the tokamak is break down. And then the term tokamak actually come from the Russian acronym, which is the toroidal chamber with a magnetic field. So when the plasma particle become energized and collide, they also begin to heat up, and the heating methods help to bring the plasma. The heating method from the tokamak, the vessel tokamak, heating up the plasma into a fusion temperature which is between 150 and 3 million Celsius. After the plasma achieve this temperature, the particle energized to such a degree can overcome their natural EM refraction on the collision to the fuse and release a huge amount of energy. This energy is a form of a heat. This heat will move to the water and become the water to the steam. As we already know about the mechanism or how tokamak works, we must know the structure of tokamak. Let's check it out. For the structure of tokamak, there are 5 important things that we must know. The first one is the vacuum vessel. The second one is a blanket. The third one is diverter. The fourth one is the cryostats. And the last one is the magnet. So, for the vacuum vessel, it provides a high vacuum environment for the plasma, improve the radiation shielding and plasma stability, act as the primary confinement barrier for the radioactivity, and provide the support for individual components such as the blanket and the divider. Cooling water circulating through the vessel's double steel wall will remove the heat generated during operation. 44 openings or ports in the vacuum vessel provide access, remote handling operation, diagnostics, heating, and vacuum system. For the blanket, it used to completely cover the inner wall of the vacuum vessel to protect the steel structure and the superconducting toroidal field magnet from the heat and high energy neutron produced by the fusion reaction. As the neutrons are slow in the blanket, their kinetic energy is transformed into heat energy and collected by the water coolant. In a fusion power plant, this energy will be used for electrical power production. For the diverter, it's situated at the bottom of the vacuum vessel. The diverter extracts the heat and ash produced by the fusion reaction, minimize plasma contamination, and protect the surrounding walls from the thermal and neutronic loads. Each of the diverters has a supporting structure in the stainless steel and 3 plasma-facing components, the inner and the outer vertical target and the dome. The cassette assemblies also host a number
of diagnostic component for plasma control and physics evaluation and optimization. For the Tokamak cryostat, it is the largest stainless steel high vacuum pressure chamber ever built. It is about 16,000 meters square. It provides the high vacuum, ultra cool environment for the vacuum vessel and the superconducting magnets. The Tokamak magnet system will be the largest and the most integrated superconducting magnet system ever built. 10,000 tons of magnet with a combined stored magnetic energy of 51 gigajoules will produce the magnetic field that will initiate, confine, shape, and control the plasma.